Hello, Charles Fader here with Hanby Environmental. Today what I'm going to show is a demonstration of the utilization of our Hanby Environmental water test kit for hydrocarbon analysis to get immediate results in real time. What we've got today here is we've got some water samples where we have a concerned landowner who has seen a vacuum truck trucking down the road adjacent to his property that has vacuumed or taken up in transporting production water from a well site to take it down to an injection well to dispose of it. The concern is that that production water, which has oil in it from the well site, he sees this vacuum truck driving down the road and it's leaking some of the production water on the road. Now his concern is that he sees this production water on the road that still has the oil in it. He sees the rainbow sheen on top of the water and he sees it go off the road into the ditch, and the concern is that the runoff is actually ultimately contaminating his property from the soil perspective, and then ultimately running off into his pond where he has fish that he eats and that type of thing. So the question is there any hydrocarbon contamination in the water? So we're going to run a simple water test here quickly and see if there's any contamination there that further warrants additional study. In the event that we quickly see if there's hydrocarbon contamination in his water, then there's obviously a need for concern. I would say that there's probably, if he's seen the contamination leaking from the truck, there's still, even if we don't detect something here, there's still reason for concern that he may want to further investigate, and that would be the fish in his pond. Even if we don't detect something here in the water, it's possible that there was contamination in the water and the fish are acting as filters and have already cleaned the water up. So at that point in time, he may want to get some fish analyzed for contamination. But prior to spending that expense and time, a simple water test will tell us if there's still some in the water. So that's what we're going to do here today. And after we do the water, I will run a second set of samples here. We have some soil samples from both the road as well as the adjacent ditch. But this is how we're going to do it. Again, we're going to use our Hanby Environmental Field Test Kit for the immediate analysis of water for hydrocarbon contamination. And the process is very, very simple. Here's our process. First thing we're going to do is pour our water sample into our separatory funnel. Then we're going to put our extract solvent into the separatory funnel. We're going to swirl the separatory funnel around, moving that solvent throughout the water sample and pulling the hydrocarbon contamination into the solvent, if there's any. Then we're going to set our separatory funnel into the ring stand and allow that extract solvent to separate to the bottom. Then we're going to decant that off into the test tube. Then we're going to add our catalyst or white catalyst powder, develop color by shaking, and compare it to the calibration photo to see the concentration level. We'll also then, if there is any color that develops, we'll read that with our mobile app to get an exact concentration, as well as be able to share that report instantly. So, without further ado, first step in the process is get our water sample. Notice though, it's got a little bit of dye because it's his pond water, but this is the water sample that we were given. The first thing I'm going to do is I'm going to agitate it up so in case there's any hydrocarbon contamination in there, it's good and spread throughout the entire water sample. We've already pulled out our ring stand here and assembled it, and we've put our separatory funnel in place, although we have left the valve open, so we're going to close that there. And we're going to... let me grab a test tube. I forgot to grab a test tube. And put that here in our test tube rack. So we're going to grab our 500 ml water sample here into our set funnel. Oop. Piece of grass came over. No big deal. All right. Now that we've got our water sample, we're going to add our extract solvent right here through the top of the, notice how it went straight to the bottom because it's heavier than water. This is the reason for capping and shaking, to increase that surface contact of our solvent with any contaminant that might be there. So, very simple. Shake, get that solvent going through there, Sometimes a little bit of pressure will build up, so we want to release the pressure here at the top. Move that solvent throughout that water sample. In this shaking process, I'm actually spilling some water here. So I'm going to need to get a paper towel and make sure that we dry this macro amounts of water here off the stem. We want to keep that stem dry as we release that water into our test tube. So we're just going to grab some paper towel. And dry up some of this water that we spilled here. I don't know if I didn't have my top to my separatory funnel on there very tight, but just roll up a piece of paper towel, put it up here in the stem. Just want to make sure that it's nice and dry, so that when we release that extract into our test tube, that we don't have water that transfers over. Some transfers over, it's not that big of a deal. So, okay. Okay. All right, we've had sufficient time for the extract to separate here to the bottom. So let's come on in here, uncap our test tube, and release our extract from here. Now we're going to watch this drop as we watch it come up in the test tube. This should be a slow trickle out. Now, what I'm actually going to do is I'm going to tap this one more time, give it a good little shake again, see if we can't get a little bit more of that solvent to drop out. See if we can't get a little bit more solvent, because we're just short of the scribed line, which is fine. It's perfectly fine to be short of the scribed line. It's better and certainly than going past the scribed line, because then we would be letting water come through. But I can see we're going to get a little bit of more accumulation of solvent there, so let's go ahead and grab that. Just to get us a little bit closer to the scribed line. Alright, so we've got our extract. Now, before I add our color development reagent catalyst, what I'm going to do is I'm going to cap the test tube and tilt it back and forth. And if there's any water in there, we would see it stuck to the sides of the test tube there. We don't see any in this case. You would see water droplets stuck to the side of the glass. So since we don't see that, we're going to go ahead and proceed forward with, notice we're a little bit short of the line, but that's perfectly okay. Now we're going to add our color development reagent catalyst to our extract to develop our color. The easy way to do that is if you'll take the glass of the vial and set it up against the glass of the test tube, and in one motion just kind of tap it on the ground, or on a hard surface. What that does is it allows that vibration to get that catalyst out into the test tube. So as you can see, we've got it all out, so we're good. And then we're going to cap our test tube and shake it. The good news here that I'm seeing is that our catalyst is still white, so I'm not seeing any hydrocarbon contamination in that water sample. So I think he's good from that perspective. Now, still, if you would like, this is a quick test just to find out if there's anything in the water, but that doesn't mean that the water didn't get contaminated before, and like I said, those fish act as filters and get that hydrocarbon contamination out. So he may want to run a test on his fish, but this is a good sign. However, what we're also going to do now, he knows there's nothing in his water, we're going to run our soil tests here to see if there's anything in the soil from the road as well as from the ditch where he took samples from. And we might as well just go ahead and do that now. Let me grab the materials to do that from our soil kit. We got 2 different soil samples. So I'm going to get 2 beakers and 2 test tubes. And I will get 2 color development reagent catalysts out. One and 2. And our 2 extract solvents for those 2 soil samples. Gonna get our color calibration photo book out for our soil test. And I will introduce that. So to do our soil test now, we're going to use our Hanby Environmental TPH soil test kit. And we're using our low range test kit, which has a detection limit of 0 to 1,000. So how are we going to do the process? Here's the instructions. The first thing we're going to do is we're going to get our scale out and measure out 5 grams of soil, which is the EPA recommended sample size for doing soil analysis. So we measure out 5 grams of soil into an empty beaker. We're going to add our extract solvent to do the extraction, stir it around to increase that surface contact of the contaminant that might be in that soil sample, and pull it into the extract solvent. We're going to decant or pour that beaker extract solvent into the test tube, add our catalyst or white catalyst powder, cap, shake, develop the color, and compare it to the picture. Very simple process. So here we go. So we've got our scale here. First sample we're going to do is this soil. The best soil they could get was from the top of the road, and we're going to get that out of this tackle box looking thing here. Quickly had to grab a spoon. My battery's low on this thing. Great. Let me get another scale real fast. Anytime you do something live, you run the risk of having a problem. Not that it's a real problem, just dead batteries, so I've got to replace the batteries in this scale real fast. I should have tested it beforehand, but that's okay. Didn't do that. Okay. So bear with me for just a minute while I exchange these batteries. Okay. And we're back in business. Okay. So again, we're going to get our scale out. Put our empty beaker on the scale. Let it weigh that and hit the tare button, tear out the weight of that glass. Come in here and measure out 5 grams of soil. So, ooh, I got a little bit high there. I got 6.82, so we're gonna take some of that stuff out. I see a couple little pebbles in there of rock. Those are extra heavy and aren't going to do a lot for us anyway, so we'll make sure we get those pieces out. Alright, we're at 5.35. We get a little bit more out of there. 5.03. So EPA recommended sample size for doing soil analysis is 5 grams. You don't have to be exactly at 5.00. You can be anywhere from 4.8 to 5.2. That's close enough in range. The most important thing is getting that 5 grams measured out as quickly as you can and getting the solvent on that soil sample. That way you trap those light volatiles from dissipating. So in this case, now we're going to grab our extract solvent and we're going to add it to our soil sample here. You can get this off the scale. We don't need that right now. Once you've added your extract solvent to that soil sample, you trap those light volatiles from dissipating so you're getting the most accurate reading you can possibly get. So this is a very sandy sample here. Then we're going to come in here and we're going to stir our soil sample around quickly to do that extraction process. Again, very similar to shaking the separatory funnel in our water analysis. Stirring the extract solvent is increasing the surface contact of the contaminant, if any, in the sample and pulling that contaminant out and into our solvent. Now we're going to grab our test tube and pour off from our beaker with our extract solvent into the test tube up to that scribed line. Scribed line represents 4.2 milliliters of the 10 mils of solvent that we put in. Okay, now that we've got our extract solvent, we're going to come over here and add our color development reagent catalyst powder. Sometimes some gets a little accumulated there at the top. So we're going to tap it on a hard surface and it's no longer there. Now we can put that into our test tube the same way we did it with the water. Contact of the glass on a hard surface is a good way to do it. That vibration gets that catalyst in there. So we've done that. And now we are going to cap and shake. I'm very easily seeing already that this soil is not white. As you can see, remember from our white result that we got from water, now look at our result from the soil. So there is some contamination there, and based on the contamination color being this tan, I'm going to say it's either diesel or crude oil, and I'll show you the reason why I say that, as opposed to say gasoline. See, gasoline on the lower end of concentration, which this is near white, so it's kind of an off-white tannish color, so we know that it's got some contamination. But notice how in gasoline we've got like a yellowish color on the low end, around 100 or less. And then as it goes to 200, we get an orangish color, and as you get to 500 to 1,000, you get a darker orange, and then you get a red in gasoline. However, when you're talking about crude oils or diesel, let's look at diesel first, because we get this tannish brown color like we got. So in this case, I'm going to be saying that this is probably falls between the 50 and the 100 in the diesel category. And then if we were to compare it to, say, West Texas crude, here we should be falling about in the same range. Yep, over here between the 50 and the 100 category. So that being the case, 50 to 100 ppm from a road is not really warrant a concern to me. That's pretty standard because cars drive up and down the road leaking oil and it's just pretty common. So I wouldn't be real concerned about a reading between 50 and 100, call it 75 ppm from a roadway. This is soil that was found on the road. Even the soil adjacent to the road is going to have that same type of contamination level just from runoff, and we're actually going to do that next. But that doesn't warrant a concern to me. It's not enough that it's going to run down the road. It's going to be consistent there all the time. It's not going to be enough to run down the road and get into his pond and cause a huge concern there. It's just pretty standard operating. It's going to be, any road in America is going to have that type of contamination. So now let's go to our second soil sample here. change spoons so we don't have any cross-contamination. Okay. Come over here. Now this bag, again, get our scale out. Put our empty beaker on it. The tare button. Let's see if we can't measure out 5 grams of soil from this particular sample. Okay. Got some rocks in there. I don't want that to take up too much weight. It's not a big deal, but I'd rather have more of the sandy soil that would be the primary holder of the contaminant, not rocks. Okay, so I'm over, so let's get some of those rocks out of there. A couple more rocks. Oh, almost the same as the last one. That's 5.08 now. There's a big rock right there. Let me get that out. That dropped us to 4.52, so let's put a little bit more sand back in there. .05. Okay, so we got our soil sample, and like I said, the more important thing is to get that solvent on that sample as quickly as possible to keep those light volatiles trapped to get us the most accurate measurement we can get. So now that we've got our extract solvent on there, we're good. Now they're trapped, they can't go anywhere. So now I'm going to put this sample back up. It does have a little bit of a stench to it, which is why I double bagged it, as well as put it in this feed bag here. I don't want to be smelling it. It smells kind of funky. Alright, so now let's stir our extract solvent around into that soil sample. See what we can extract out of it. It's a nice and sandy sample, so very easy to make an extraction from. I can already tell this is definitely higher concentration. The reason why I say that is, let me show you. You know that our extract solvent is a nice clear solvent here that we're using. Before I've even poured it in a beaker, you can see how dark this is. So let's go ahead and pour our extract into our test tube up to our scribed line. Telltale sign of high contamination is when your solvent is no longer clear. So this particular sample from this feed bag is highly contaminated, no doubt. Look at this. We got, this is how our solvent starts out. This is our extract from that sample. So much, much higher concentration due to this dark solvent color. You're going to see as we develop the color with our test kit that this is highly contaminated in comparison to this other sample that we just ran. So let's do this. Get this stuff out of our way. So the next step in the process to add our color development reagent catalyst, our white catalyst powder. It's very stark white, you can see. And as soon as we drop this catalyst in there, as soon as we drop it in, you're going to see this color start to develop. And we're going to do the same thing as before. There we go. So we haven't even shaken our sample yet, and you can see that that stuff has already changed color to that brown. Now watch what happens when we shake our sample. A lot darker than that other one. So this second sample has a lot more contamination. Like I said, I could smell it when I opened the bag. So that first sample from atop the road, very light in color, but still contaminated, probably about 75 parts per million. But now look how dark this result is. And this is from the ditch on the side of the road.
much higher in concentration. This is going to be closer to, you know, the 1,000 ppm, I would say. So this one over here was at 75, and this one's going to be closer to 1,000 ppm. Now, and likewise, let's also compare them. That's the West Texas crude calibration photo. Let's also compare them to the diesel photo because of the color match, and we'll show the same number we get there. The calibrations are set up the same, so it doesn't matter which one you compare the result to, you're going to get the same number. So as before, where we had this number that fell in here at 75 in the diesel versus this guy is over here near the 1,000. So it doesn't matter which calibration photo we compare these two results to, we get the same number. 75 in the diesel, about 750 to 1,000 in the other sample. It's the same numbers we got when we compared it. When we compared these two sample results to the other calibration of West Texas crude, we got the same results as well, which is again the 75 there, 750 to 1,000 over there. So we're using the human eye to make that measurement. So let's replace the human eye with our mobile app. And in doing so, we're going to go to our phone, go to our mobile app, hit New Analysis. We're going to create a new folder here for these particular samples, and we're going to call it Victoria. Whoops, I didn't type that very well. Victoria. Should probably take my gloves off. Victoria vacuum truck samples. All right. So the first thing we're going to do, let's go capture our photos. So let's come in here and say our preliminary judgment call. Let's capture our photos with our camera instead of doing it live within the app. Our preliminary judgment call for this particular one is we're saying that it falls over here about 75 ppm. So we're going to take our result, compare it to the calibration photo, and take a picture. Then we're going to go to the back and put our result up against this white background and take a picture of the result against the white background. And you know what? We're going to do the same for our second sample, and we're just going to store our pictures right now. We said this one's over here close to 1,000, so we're going to come in here and take our result against the calibration photo. Let's call it the preliminary judgment call. Do the same thing. Go back here to the white background and take a picture of that result. It's the white background. Okay, we've got our two samples here. I compared those against the West Texas crude because we know that there's, even though the color matches up between crude, the West Texas crude as well as the diesel, and that's why I was comparing to both calibrations, we do know that this is a vacuum truck that is actually transporting production water. So why, even though the color matches between the crude oil and the diesel, why did we choose the crude oil over the diesel? Because production water most likely has crude oil in it because it's coming straight from the well. Although, you know, they could have some diesel in it from the drilling mud that was used in the process. But nevertheless, it doesn't matter which one we compare the result to. We're still going to get the same answer. So back to our mobile app, and I'm going to back out of it just like I'm starting from zero. So we named our folder that we're going to put this in. Next, we're going to access our camera roll here. And we're going to go to that preliminary judgment call and save that. Then we're going to go and get our sample against the white background right here. It's going to, when we do that, it's going to activate our cropping function. We're going to bring our cropping function in. We want to bring it in from all sides. We don't want the right, left, or bottom sides of those test tubes. Those curvatures cause shadows. We want to bring it in from all there. Also, did you notice there is a shadow over here on the left side? So we don't want that shadow to affect much of our result, although it would be referenced out anyway, or it'd be averaged out anyway. So we're going to focus more over here to the right where we don't have that shadow in play. And so right in here is where we're going to crop. Done. Next, this is a soil sample that we're doing. We're going to name it again, Victoria Vacuum Truck. And this is the lower one. This is from the road top sample. Okay, so we named our sample, and going to come in here. Did we use a high range or a low range? We used our low range, 0 to 1,000 ppm solvent. It's a known contaminant. We're going to go to our contaminant list, and we're going to select the West Texas crude right there to tell it which calibration photo to compare our result to. Get result. Wow. So it was actually much darker than we thought it was. The result says it's 802 ppm. And as we look at our, now that's what's beautiful about the mobile app and the standardized and the optical here, is that now that we have that, the mobile app's told us, we take our result, and if we come over here and we compare it back to the calibration photo just to see what it told us, it's, you know, it is way over here. It is much darker than we thought it was. See, the mobile app uses the intensity of the color to compare it. So we go into our mobile app, it says right there, here's what the calculation is, the 802 ppm. So we're going to select it and say generate report. So that one's done. Now let's go to the second sample. This is Victoria Vacuum Truck. This is our folder where we want to save it. Go get our pictures from our camera roll. Here's the second sample. Choose. That was the preliminary judgment call against the calibration photo. Now we're doing the sample itself. Activating the cropping function. Gonna bring in the crop. Remember, we want to be inside the edges of the test tube. In here. Done. Next, soil sample. This is the ditch road side ditch sample. We did a low range test. We did a known contaminant. We know what our contaminant that we're comparing it to is, the West Texas crude oil. Get result. 1026 ppm. You calculated the number for us. So we select it, hit generate report. And here's our results in our past analysis. So we went to, let's go back out. We went to past analysis, and then they're right there. So that result there was the 802 ppm, which was the first one. And the second one is right here at the 1025 ppm. And if we want to share that with somebody, we just go here, share it however we want. So that's it. So in our determination here, what we've done is we determined that in his water sample from his pond, that there really is no contamination there as far as hydrocarbons go. Then, from the sample that he took from the road top, it's way over here at 803 ppm. And then, from the ditch, the roadside ditch, the result is over here. As you can see now, it's fully developed the color. It's over 1,000 at 1,025 ppm. So there we go. There you have it. Now, that being the case, you know, most roadsides in America, because of the traffic flow that moves down them, most sides of America, if you go to the highway and you take a soil sample and you test it, most highways in America have between 500 ppm contamination in a very rural area to, you know, 1,000 to 2,000 ppm contamination next to a highway that's highly traveled. So that's just kind of standard, and because of the amount, the volume of traffic flow that's moving up and down the road. So that being the case, getting the results in 800 and 1,000 ppm from a roadside and from a road top, I wouldn't be highly concerned that that was actually coming from just the vacuum truck. That would actually be, you know, pretty standard from anywhere in the roadside in America. The fact that we got such a low concentration there and a non-detect in water would lead me to say that, you know, it's pretty safe that there's not a lot of contamination being run off into his pond that he should be concerned with. I would say this is pretty standard. So thank you for tuning in today, and glad you got to see how easy and quick our analysis can be with our two test kits. In this case, it was a little bit longer than would normally take. It would normally take 6 minutes to do a water analysis and 4 minutes to do a soil analysis. It was rather slow because I was explaining step by step what we were doing and why we were doing it. But once you've utilized the product before and you have some experience, you should be getting your soil analysis in 4 minutes, water analysis in 6 minutes, within 10% of a lab result for $25 a test. So real value proposition by utilizing our kits out in the field. So thank you again for your time.